Welcome back. Today's topic is related rates, and it's another application of differential calculus. So the related rates is somewhat similar to optimization and modeling, and you can follow similar steps. So let's just write the steps for solving these related rates problems. So the first thing to do is to figure out what's being asked and draw a picture. Just a quick sketch or diagram just to visualize what's going on. The second step is to write down the information that you get. But write down this information in terms of time and in terms of the changing, like for example if volume is changing you can write dV over dt and stuff like that, so you can figure out in the end it's easier to plug it back in. Third is to find out what's being asked and to write an equation. So just write equation. So write an appropriate equation for the question. So if the question is about the volume of a cone, you should write the equation for the volume of a cone and then go from there. Fourth is to find a relationship between the variables. So again, if we take a cone example, there is a relationship between the height and the radius, and you can find a simple ratio and make it all into one variable. And step 5 is to differentiate with respect to t. So with respect to time, so you want to differentiate with respect to time. And the final step is to just solve for the unknown. There should only be one variable left, so you can solve easily for the unknown variable. Alright, so those are 6 basic steps. And so let's try an example. And let's actually do an example to do with the volume of a cone changing. So you have a cone, a conical reservoir, let's just say, and water is flowing out at a rate of 50 meters per second. So you have this reservoir, and the dimensions are radius is 45 and the height is 6 meters. So radius is 45 meters and the height is 6 meters, and water is flowing out at a rate of 50 meters cubed per minute. So from that we can say dV over dt is equal to, and since water is flowing out, it's negative 50 meters cubed per minute. So the question is, how fast is the water level falling when the height is 5 meters? So let's just write that down. How fast is the water level falling when the height is 5 meters? So the question is basically asking for the change of height with respect to time. So this is dH over dt. How fast is the water level falling? So we can start first by writing an appropriate equation, which is one of the steps, and just say V is equal to 1/3 pi r squared h. This is the volume equation, and from here we should figure out how, and since we're being asked for dH over dt, once we differentiate we only want dH over dt. We don't want to have dr over dt variable in this. So we should put r in terms of h. So to do this, we can just make a simple ratio of the height and the radius. So you have 45 and you have 6. So r over h is equal to 45 over 6. So 6r is equal to 45h. R is equal to 45h over 6, which is equal to 15h over 2. Plugging this newfound value of r in terms of h back into here, we get v is equal to 1/3 pi 15h over 2 squared, that's the new r, times h, if we square that, we get 1/3 pi 225h over 4 squared times h, giving us v is equal to 225 over, or rather just 1 over 12, or pi over 12 times 225h cubed. So now we have the v in the volume in using just one variable, h. And since we know that the volume is changing at a rate of negative 50 meters cubed per minute, and we want to find the change of height with respect to time. Alright, so now we want to differentiate this, since we have the rate of change with respect to time of the volume, and we also want to find the rate of change of height with respect to just rate of change of the height. So we want to differentiate this, and we get v over dt is equal to 225 pi over 12. We can just leave this as just one big constant times 3h squared dh over dt, as we are differentiating with respect to time. And this we get negative 50. Now we start replacing the terms, is equal to 225 pi over 12, or well, actually pi over 4, as this and this just cancel out, get a 4 there, times h squared. So the h at this point, we're asked how fast is the water level falling when the height is 5, so h squared is 25 times dh over dt. So we only have one variable here, and or one unknown rather, and that's dh over dt. So now we can cross out this and this, and just get a 2 on this side, so we get a negative 8 is equal to 225 pi, because I took the 4 in here, and dh over dt, and solving this, dividing negative 8 over 225 pi is approximately negative 0.0113 meters cubed, or meters per minute. And that is the change in height, so it's like negative 1.11 or negative 1.13 centimeters per minute. That's another better way of writing it. So that's the change in height.